Hello students, welcome to Made Physics Easy. Today we are solving the AS level 9702 paper 1 multiple choice questions of February March 2023. This session aims to address those queries and provide you with a comprehensive understanding of the concepts. So what we are waiting for? Let's get started. So for first questions, what represent the physical quantities? So we know that the physical quantity is a quantity that can be quantified by measurement. So the physical quantities possesses at least two characteristics in common. First, the numerical value, and other is a unit. So out of these three, option C having a numerical value as well as a unit. So option C is correct. Question number 2. The relationship between the variable d and t is given by the equations 1 upon t is equal to b upon root d plus c, where b and c are the constant. The unit of d is meter square and the unit of t is s. So what are the unit of b and c? We know that from the principle of homogeneity, which state that the unit of each terms of the equation on both sides are same. So using these principles, we can write the unit of 1 upon t, which is equal to inverse second. So this is the unit of b upon root d as well as the unit of c also. So the unit of c is equal to s inverse, and unit of b upon root d, which is also equal to s inverse. So unit of b is equal to s inverse root under, and unit of d is meter square, so which is equal to meter per second. So out of 4, this option B is correct. Unit of B is meter per second and unit of C is per second. A hollow cylinder which is open at both ends has a radius of 3 plus minus 0.1 centimeter and the length of 15 plus minus 0.1 centimeter. What is the value with its absolute uncertainty of the surface area of the cylinder? So first of all, we have to find the area of the hollow cylinder. So the area of hollow cylinder can be written as 2 pi RL. This is equal to 2 into 3.14 into 3.0 into 15.0. So the radius is having two significant figure 3.0, and the length of the hollow cylinder having a three significant figure 15.0. So the answer will be the least number of significant digit to be measured value of the two. So this is, so here a is equal to, this come out to be 282.6. So now as per the rule of multiplication of two number, this we have to consider for the two significant figure, the list of the R or L. So the R is of two significant figure and L is of three significant figure. So we have to take the list of both. So this come out to be 280. Now for finding absolute uncertainty of A, we can write del A is equal to del R upon R plus del L upon L multiplied by 100. So this is equal to 0.1 by 3 plus 0.1 by 15 into 100. So this will be 0.033 plus 0.067 into 100. So this will be 10. So your answer will be option A. A snooker ball of a mass 0.20 kg has a collision so that its direction of a movement changes by an angle 90 degree as shown. The ball has a speed of 0.40 meter per second before the collision and the speed of
0.30 meter per second after the collision. What is the magnitude of change in momentum of the snooker? So let's say before the collision it's having a momentum of P1 is equal to m v1. This is equal to m is 0.2 into 0.4. So this come out to be 0.08. And after the collision, let's say momentum is P2, which is equal to mv2 0.2 multiplied by 0.3. This is equal to 0.06. Now if we want to draw the vector diagram of both the momentum, so this is P1 and this is P2. But in the question it is asking the change in momentum. So we need to find P2 minus P1. So this is P2 and minus P1 is the opposite direction of P1. So this is P1. We can write this is P1, this is P2. This is P2 minus P1. So this is clear a right angle triangle where the we can write P2 minus P1 magnitude is equal to under root P1 whole square plus P2 whole square. So this is equal to under root 0.08 whole square plus 0.06 whole square. So after solving you will get, so this come out to be 0.01. So under root 0.01 is 0.1. So out of this, option B is correct. A ball is kicked upward at an angle of 45 degree to the horizontal ground. What after a short flight the ball returned to the ground. It may be assumed that the air resistance is negligible. What is the never zero during the flight of the ball? So in the projectile motion, if we neglect the air friction, the only force that act on a body or a ball is a gravitational force which is acting in the downward direction. So this is gravitational force, it is acting in the downward direction. Thus the horizontal component of the velocity remain constant because there is no force acting on the horizontal directions. So the horizontal component at any point, so this is the velocity, horizontal component at any point is same because there is no force acting in the horizontal direction. Therefore option B is correct. The graph shows the variation of the graph shows the variation with the time of the displacement s of an object. Which graph represent the variation with respect to time of the acceleration a of an object? So this is the displacement versus time graph. First we need to draw the velocity versus time graph, and we know that the rate of change of displacement with time is velocity. So when we plot velocity along y-axis and time along x-axis, the slope of displacement time graph gives the velocity produced. So this is the displacement versus time graph. If we draw the slope of this graph with respect to time, it will give the velocity versus time graph. So we divide this in different sections. This is T1, this is T2, this is T3, and this is T4. So up to 0 to T1, the slope is positive as well as constant. So angle is between 0 to 90 degree. The tan theta between 0 to 90 degree is positive and constant. So we can draw velocity versus time from 0 to T1. positive and constant. This is T1. From T1 to T2, the slope is negative because the theta falls between 90 to 180 degree. So the tan theta value between 90 to 180 degree is negative. The slope is negative. So this is the velocity between T1 to T2. Similarly, for T2 to T3 is same as 0 to T1, and for the rest of the journey is like this: T3, T4. Now we know that the rate of change of velocity with time is accelerations. So when we plot velocity along the y-axis and time along the x-axis, which is as drawn here, the slope of velocity time graph gives the acceleration. So in the questions it is asking the accelerations versus time relationship. So we need to draw the acceleration versus time graph from this velocity versus time graph. So from 0 to T1, the velocity is constant. So there is no change in velocity. This means that acceleration is 0. Similarly, for T1 to T2, the velocity is constant but negative. So here in this region also, the velocity is constant but negative. It means that its acceleration is also 0. Similarly, for T2 to T3, positive constant, acceleration is 0, and T3 to T4, negative constant, acceleration is 0. But we need to here we observe that at point T1, the velocity abruptly changed from positive to negative. So at this point, just before the T1, let's say the value is +2, and just after the T1, the value is -2. So we know that acceleration is equal to change in velocity with respect to time. Change in time is very minimum. So we can write change in velocity is -2 -2, or let's say some value, let's say 10 of change in time. So this will become -40. So at point T1, the acceleration is some value but negative. Similarly, if we draw for point T2, the acceleration come out to be some positive. It come out to be some positive value. So here I am taking numerical value just for understanding. So if we want to draw the acceleration versus time graph at point T1, T2, T3. So if we want to draw acceleration versus time graph from 0 to T4, so acceleration is between 0 to T1 is 0. So there is no acceleration between 0 to T1. But at point T1, there is a negative acceleration. It having some value. I don't know what value it is. At point T2, when the velocity is changing from negative to positive, acceleration is come out to be some positive value. Similarly, for point 3, acceleration come out to be some negative value, and for T4, acceleration come out to be some positive value. So out of this, option D is correct. So which expression define force? We know that force is equal to mass into acceleration. So we can write force is equal to mass, and accelerations we can write change in velocity. Let's say v2 is the final velocity and v1 is the initial velocity with respect to time. So this will become, if it is mass is m, so we can write m v2 minus m v1 with respect to time. So F is equal to mv2 is final momentum and mv1 is initial momentum with respect to time. So this is change in momentum with respect to time. So out of this, for 7, option D, I think it is correct. Change in momentum upon time taken. A ship of mass 8.4 into 10 to the power 7 kg is approaching a harbor with a speed 16.4 meter per second. By using reverse thrust, it can maintain a constant total stopping force of 920,000 Newton. How long will it take to stop? So we know that in ship there is no brake because there is no wheel in the ship. The speed of the ship is decreased by applying anti-thrust or the reverse thrust. So how it can be applied?
So for a ship, there is a propeller which is at the back side of the ship. So when this propeller moves in a clockwise direction like this, then the rotor of the propeller push the water in backward direction like this. So in return, water push the ship in opposite direction as per Newton's third law. In this way, the ship move forward. So for a reverse thrust condition, what happen? Now the propeller move in anti-clockwise direction. So in doing this, the rotor of the propeller or the blade of the propeller push the water in forward direction. So the water push the ship in backward direction. So there is a reverse thrust which oppose the motion of the ship.
And after some times the speed slow down and its speed become 0. So let's say this is the ship which is moving in this direction. So when it applied the anti-thrust, it will apply a force in this direction. So when the force is in opposite direction of the speed, there is an acceleration in this direction. So here the final velocity is 0. Momentum equations we can write: net force on the ship is equal to change in momentum with respect to time. So this, if this is a positive direction, the force is in the negative direction, so we can write minus net force is 920,000, which is equal to final momentum, which is 0 because the velocity is 0 at the end, minus initial momentum. Initial momentum is mass into velocity. So mass is 8.4 into 10 to the power 7 into 16.4. This is the speed in this direction upon time. So we can write t is equal to, so this is equal to 1497 second. So if we convert it, because there is some answer in minute and some answer is second, so there is no option match with the second. So if we convert it in minute, so t come out to be 24.96, so which is equivalent to 25 minute. The velocity time graph of 4 different objects are shown. Which graph represent an object falling from the rest through a long distance in the Earth atmosphere? So if we see if we see all the options available here, in option B, the initial velocity is not 0. So this is not 0. Therefore, we will not consider option B. We will see in option A, C and D. We know that the area of velocity versus time graph is displacement. So the area of this A is this much, area of C is this much, and the area of D is this much. So comparing the area of option A, C and D, it is clear that the area is maximum in D. So D having a maximum area, it means that D having maximum displacement, and since the object is falling in the Earth's atmosphere, we may suppose that object is in the one-dimensional motion. So in one-dimensional motion, the displacement and the distance is same. Since the displacement of
D is maximum, therefore the distance of D is maximum. So out of these all four options, option D is correct.
Which statement about the collision is correct? So question number 10. The first is kinetic energy is conserved in all the collision. Momentum is only conserved in perfectly elastic collision. The relative speed of approach is equal to the relative speed of the separation for perfectly elastic collision. So let us consider there is a two ball. So let us consider there is a two ball whose mass is m1 and initial velocity is u1 and mass m2 and initial velocity is u2. So this is a situation before the collision and this is after collision. So from momentum conservations we can write m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. We can further solve these equations and write m1 u1 minus v1 is equal to m2 v2 minus u2. So let's say this is equation 1, and since the collision is perfectly elastic, so the kinetic energy is also conserved. So we can write kinetic energy before the collision is equal to kinetic energy after the collision. So from here we can, half is common, so it can be cancelled out. So we can write m1. So this can be further expand as u1 minus v1 into u1 plus v1. So this is equal to m2 v2 minus u2 and v2 plus u2. So let's say this is equation 2. So divide equation 2 by equation 1. So we can get, if we divide by equation 1, this equation m1 u1 minus v1 m2 v2 minus u2. So these terms will cancel out, these terms will kill these terms. So we get u1 plus v1 is equal to v2 plus u2, or u1 minus u2 is equal to v2 minus v1. u1 minus u2 is the difference of these two velocity. So this is a relative speed of approach, and v2 minus v1 is the relative speed of separation. Option C is correct. A satellite uses two thrusters to adjust its motion in space. Each thruster exerts a force of 40 Newton on the satellite. The line of action of each force is perpendicular distance of 2.3 meter from the center of gravity of the satellite. These two parallel forces act in opposite direction. What is the magnitude of the torque and the resultant force acting on the satellite due to the two thrust force? So there is a two thrust force of 40 newtons. So let's say this is A and B. So A try to move the satellite in this direction, and thruster B is trying to move in this direction, force into the perpendicular distance. So since the two moment are in the same directions, we can add the two moment. So moment of A plus moment of B is equal to the total moment of the satellite. So the total moment is equal to moment of A plus moment of B, and since both are in the same direction, in the clockwise direction, so the moment will add up. So this will become 40 into 2.3 plus 40 into 2.3. So after adding, it will become 184, and the resultant force if this is a satellite, there is a one force acting in this direction and one force is acting in this direction. So, and the both force are equal and opposite, so the resultant force acting on a satellite is 0. So out of this, total torque is 180, because we got 184, which is near to 180, and resultant force is 0. The diagram shows two way of hanging the same picture. Okay, diagram 1 and diagram 2. In both cases, a string is attached to the same point on the picture and the loop symmetrically. In diagram 1, the string is shorter than in diagram 2. So let us draw a perpendicular distance here and here. So if this is angle theta, say, so this is also angle theta, and let's say this is some another angle, let's say phi, and this is angle phi. Nail is in equilibrium, so we can draw all the forces on acting on nail. This is r1 and this is angle theta, this is angle phi. So we can, for the diagram 1, we can write r1 is equal to 2t1 cos theta. For diagram 2, we can write r2 is equal to 2t2 cos phi. T1, this is T1, this is T2, this is T2, and this angle is theta, this is theta, this is phi, and this is phi. So let's say it's having some weight W. Force balance equation for this two diagram. So we, for the D1 diagram 1, we can write T1 cos theta plus T1 cos theta. This is T1 cos theta is equal to total weight, and for D2 we can write T2 cos phi plus T2 cos phi is equal to W. So from here, 2T1 cos theta is equal to W and 2T1 cos phi is equal to W. So it means that T1 cos theta is equal to T2 cos phi. So from here we can say that T1 upon T2 is equal to cos phi upon cos theta. But from the two figure, it is clear that theta is greater than phi. And if we observe the cos theta relation with the theta, cos 01, cos 30.86, cos 45.707, cos 60.5, and cos 90. So as we increasing from 0 to 90, the cos theta is decreasing. So with increase in theta, the cos theta is decreasing. So we can say that if there is a two angle theta and phi, and the relation between theta and phi is such that theta is greater than phi, so cos theta is less than phi. We can write cos phi upon cos theta will be greater than 1. So from here we can write T1 upon T2 will greater than 1. So T1 will greater than T2. And if you see, R1 is equal to 2t cos theta and R2 is equal to 2t cos phi. But 2t1 cos theta is W and 2t2 cos phi is also W as shown here. Both are equal to W, weight of the diagram. So R1 and R2 both are equal. So R1 is equal to R2. So out of these three, I think option B is correct. R1 is equal to R2 and T1 is greater than T2. An object shaped as a homogeneous rest with its flat surface on the table. The object has a radius r and its density is rho. The volume of the sphere is 4 by 3 pi rq. The average pressure does the object exert on the table? So this is a hemisphere. So the contact surface area is pi r square. So these are the contact surface area, and the contact surface area A can be written as pi r square. Now we know that the pressure is equal to force per unit area, and force is equal to mg, because only gravitational force act on the table upon area. M can be written as density into volume. So density is rho and volume is 2 by 3 pi r cube, because the total spherical volume is 4 by 3 pi r cube, but this is hemisphere. So we can write 2 by 3 pi r cube into g divided by pi r square. So after solving we got 2 by 3 rho pi, kill this pi, r into g. A probe is used to monitor the quality of the water in a sea. The probe is suspended by the vertical string which is attached to a sphere. The stationary sphere floats in equilibrium on the surface of the sea as shown. The sphere has a weight of 5 Newton. The probe has a combined weight of 2 Newton. The density of the seawater is 1.03 into 10 to the power 3 kg per meter cube. The upthrust acting on the probe and the thread is negligible. What is the volume of the sphere below the surface of the sea? So we have to consider, so the upthrust force act on the sphere like that. So there is a net upthrust for after the vector with the vector summation of all these forces. Let's say this is the total upthrust, Fu I can say, and if I consider the sphere as a point, and there is a downward force act on a sphere, let's say W. So this W is summation of the weight of a sphere as well as the weight of probe and string. So W is equal to 5 plus 2, which is equal to 7 total weight. So we know that the upthrust force is equal to density into volume of water displaced by the sphere into g. So from this free body diagram we can say that F upthrust is equal to W. So rho volume of water displaced into g is equal to 7. So volume of water displaced is equal to the volume of sphere below the surface. So volume of water displaced is equal to the volume of a sphere below the surface of water. So V is equal to 7 upon rho g. So this is equal to 7 upon 1.03 into 10 to the power 3 multiplied by g is 9.8. After solving we got 6.93 into 10 to the power minus 4. So this is the volume of a sphere below the surface of sea. So out of this 6.93, out of this option D is correct. What is the center of gravity of an object? So by definition we know that the center of gravity is a theoretical point on a body where the body total weight is thought to be concentrated, or we can say that the weight of object may be considered to act. So out of 3 from the definition of center of gravity, option B is correct. So a system with an efficiency of 74% wastes 230 watt of power. So what is the useful output power of the system? We know that efficiency is equal to output power divided by input power, and waste power is equal to input power minus output power. So we can write P0 is equal to P1 minus PW. Efficiency is equal to Pi minus Pw upon Pi. So now putting the value, efficiency is 74, 0.74 is equal to 1 minus waste is 230 upon input power. So P input is equal to 230 upon 0.26. So Pi from here we can find Pi is 886. So output power is equal to input power minus waste power. So this come out to be 886 minus 230. This come out to be 665. So 665 is near to 650. A projectile of mass 0.25 kg is at a height of 30 meter above horizontal ground and traveling at a speed of 15 meter per second. A short time later, it is at the height of 35 meter above the horizontal ground and traveling at a speed of 5 meter per second. How much work is done against the air resistance during this time? So let's say this is the situation. Let initially the projectile is at this point and it's at the height of initially it is at the height of 30 meter, and then after some time the projectile is at here. So it is at the height of let's say 35 meter as given in figure. Velocity is in this direction, and there is a resistance force due to the air act in this direction. So there is a net displacement here, let's say D. So D is the displacement, and this is the height covered at true instant, which is equal to 35 minus 30, which is equal to 5 meter, and let's say this angle is theta. So during the upward displacement, our resistance force, which is R here, and also the gravitational force, it does negative work because projectile is moving upward and these two forces acting downward. So a gravity is acting in downward direction, weight, and resistance is acting opposite to the velocity direction or the speed direction. So these two forces, air resistance and gravitational force, it does a negative work. So both force tends to transfer energy from the projectile. So we can write change in kinetic energy is equal to work done by all the forces. So there is the two forces, gravitational force and resistive force by air. So change in kinetic energy is equal to work done by all the forces. So what is change in kinetic energy? Change in kinetic energy is half m v square, v is the final velocity, minus half m u square, u is the initial velocity. So this is equal to work done by the gravitational force, wg plus wr. But if you see, the gravitational force act in this direction, mg, and the displacement is in this direction, d. This is angle theta, so this is angle 90. So we know that the work done by the force here, the gravitational force, is equal to force multiplied by displacement, here it is d, and the angle between displacement and the force, which is cos, angle is 90 plus theta. This is the angle between the displacement and the force. F into d, cos 90 plus theta is minus sine theta. So this is equal to minus f into d sine theta. But d sine theta is h. H is equal to d sine theta. So this is equal to minus f into h. And f is the weight, which is equal to m into g. So minus m g h. Putting the value of all this figure, this is equal to wg is minus mgh minus 0.25 into 9.8 and h is 5 plus resistive work done by resistive force wr. So if we solve this terms is come out to be minus 25. So this is equal to minus 12.25 plus work done by resistive force. So work done by resistive force is minus 12.75, and of course negative signs shows that the work done is in the opposite direction of the displacement. So option B is correct. A spring has an unstretched length of 4.5 centimeter. The spring is fixed at one end and a force of 30 Newton is applied to the other end, so that the spring extend. The spring obey Hooke's law and has a spring constant of 420 Newton per meter. What is the strain of the extended spring? Is this is a spring, it's having some unstretched length, so with this come out to be 4.5 centimeter. Now there is a force applied on a spring in this direction, 35 Newton. Because of this force, the spring got extended and its spring constant is 420 Newton per meter. So when a force is applied, there is extension in the spring. So there will be a force resist by the spring, which is of the amount of kx. So we can write 35 Newton is equal to kx. So x can be found out to be 0.0833, and we know that so strain is equal to change in length upon original length, which is equal to 0.083 into 10 to the power 2 upon 4.5. Here one thing to note that there is a common mistake done by the students. This x is come out to be in meter. We have to change it in centimeter because L length is in centimeter. So this will come out to be approx 1.85. So out of this, option C is correct. A wire is fixed at one end and extended by the force that is applied to the other end. The force is slowly increased from the zero and then slowly decreased back to the zero. The force extension graph for the wire is shown here. The graph line for the wire being loaded is same as the graph line for the wire being unloaded. There is extension in the wire. So as we increase the force, this is the this is the diagram during the extension. So when we release the force, when we release the force, it will come back to its original position. So like that.
We know that the elastic region is the region in which material can be deformed, and when it released, it will come back to its original position.
But if it enter the plastic region, there will be a net permanent deformations. So if it reach up to here, so there will be a net permanent deformation, this. But this is not the situation like that. It will return back to its original position. So it will be a perfectly elastic. So the deformation is elastic only. There is no plastic deformation because there is no net extension. So option B is correct. In a progressive water wave, two particles P and Q on the surface of water are a fixed horizontal distance apart. P and Q oscillate vertically. At time t is equal to 0, the wave is at as shown. Which graph best represent the variation with time t of the phase difference phi between the oscillations of the water particle P and the oscillation of the water particle Q? So point P is at a maximum amplitude and point Q is at a minimum amplitude, let's say. Or the phase difference, we know that the phase difference is equal to 2 pi upon lambda into path difference, delta x. So this is the delta x. So delta x is the path difference of the two wave. So delta x is the path difference of point Q and point P. So phase difference can be written as 2 pi upon lambda. Lambda is the wavelength. This is lambda. So here we observe that 2 pi is constant, lambda is constant, and delta x is also constant. It independent of time. So phase difference between 2 points is independent of time. It will remain constant at any time. So out of these three, this 4 A, B, C, D, option D, I think it is correct because it is independent of time. It is constant throughout. Which statement about the longitudinal wave and transverse wave is not correct? So both wave can be polarized. No, it is not correct. Only the transverse wave polarized because the polarization is the property of transverse wave only. The longitudinal wave is not polarized.
So the option A is correct.
An observer hears sound emitted from the moving source. The observed frequency is less than the frequency of the sound emitted from the source. What could be the reason for this? So if source is moving, we know that from the Doppler effect, absorbed frequency is equal to velocity of sound upon velocity of sound plus minus velocity of source into the original frequency. So if the source is moving away from the observer, the absorbed frequency is velocity of sound upon velocity of sound plus velocity of source into the original frequency. So when so in this case the observed frequency is less than the emitted frequency. So so the source is moving away from the observer. 22A. So question number 3. What is the approximate range of frequencies of electromagnetic radiations visible to the human eyes? So we know that the visible frequency is between 380 to 700 nanometer, and also we know that nu is equal to c upon lambda, where c is the speed of light. So if I see the option, then this part is same in all the options, but this part varies. So let's try to find the frequency, one frequency. So this come out to be
789 terahertz. So in option D is correct. It is 430 to 750. A beam of vertically polarized light is incident normally on the polarizing filter. The filter can be rotated so that it is always in a plane perpendicular to the beam. The transmission axis of the filter is initially vertical. The filter is first rotated clockwise by an angle 30 degree so that the transmitted light wave have intensity I30. The filter is then rotated clockwise by further angle of 30 degree. Let us find the intensity I30. Let the incident light intensity is I0 and this will become I30. So we can write I30 is equal to I0 cos square 30. Now this filter is then further rotated clockwise by 30 degree. So it means that it is rotated by 60 degree from the initial position. The situation is something like this. Now this angle will become 60 degree. In this case, the incident light is I0 and this is I60. So for I60 we can write I60 is equal to I0 cos square 60. So let's say this is equation 2 and this is equation 1. Divide equation 2 with equation 1. So it will become I60 upon I30. This is equal to I0 cos square 60 upon I0 cos square 30. So this I0 kill this I0. Cos square 60 is 1 by 4 and cos square 30 is 3 by 4. So we can write I60 upon I30 is equal to 1 by 3. So I60 is equal to I30 upon 3. So it will come out to be 0.33 I30. So I60 is 0.33 I30. So out of these options, option B is correct. A musical instrument is made using a long tube with a mouthpiece at one end. The other end is open and flared as shown. The musician maintains a stationary sound wave with a node at the mouthpiece and an anti-node at the other end. The lowest frequency of sound that the instrument can produce is 92 Hz. Which different frequency of sound can be produced by the instrument? So in case of pipe with one closed and one open end, the closed end will produce node and the open end will produce antinode. And the resonance frequency which is given as F is equal to V upon lambda. So this is equal to N V upon 4L, where L is the length of long tube and N is here 1, 3 and 5. So in the question, the lowest frequency of the sound is given, which is 92 Hz, which come out to be for N is equal to 1. So F1 is equal to 92 Hz for N is equal to 1. F2 is equal to 3 into 92, which is 276. F3 is equal to 5 into 92, which is equal to 460. And F4 is equal to 7 into 92. So this come out to be 644. So option C is correct. Two waves of equal frequency and amplitudes are traveling in opposite directions along a stretched string. When they meet, they form a stationary wave with 3 nodes and 2 antinodes. The frequency of both waves is doubled and a new stationary wave is formed. How many antinodes are there in the new stationary wave? So the situation which is given in a problem is can be depicted something like this. So here there is a one node here, one node in middle, and one node in end, and there is a two node here, over here and here. Now for this standing wave, we can write position of a antinode x is equal to n plus 1 by 2 into lambda by 2, and the position of node, this is antinode, and the position of node is equal to n lambda by 2. So for x is equal to 0, there is a first node here, here is the first node for n is equal to 0, for n is equal to 1, for n is equal to 1, and for n is equal to 2, this is node for n is equal to 2. So the total length of the string is lambda. Total length of the string is lambda. For antinode, we can write x antinode first for n is equal to 0, which is at lambda by 4. Another antinode, because there is two node in the question, is at for n is equal to 1, 3 lambda by 4. This is lambda by 4 for n is equal to 0, and this is 3 lambda by 4. Now wavelength and frequency are related through a relation lambda into frequency is equal to v, where v is the speed of wave along the string. So when the frequency is double, the wavelength is half. So now the new wavelength is half of the previous wavelength. So the new wavelength lambda dash is equal to lambda by 2. So we can write a equation for the new frequency for antinode x dash a is equal to n plus 1 by 2 into, now in place of lambda we will write lambda by 2 for the new wavelength by 2. So this is equal to n plus 1 by 2 into lambda by 4. Now these whole terms should be less than lambda, because the last lambda is at final node, so the last antinode will be just before the last final node. So these whole terms should be less than lambda. So we have to find the possible number of n for which this inequality will be true. So let for n is equal to 0, LHS left hand side will be lambda by 8. For n is equal to 1, it will be 3 lambda by 8. For n is equal to 2, it will be 5 lambda by 8, and for n is equal to 3, it will be 7 lambda by 8. But if we go for n is equal to 4, then it will become 9 lambda by 8, which is more than lambda, which is not possible. So the possible cases is n is equal to 0, n is equal to 1, n is equal to 2, n is equal to 3. So total number of antinode will be 4. So this option D is correct, 4. We have learned that when a wave strikes a sharp corner, then it diffracted from its original path. So if a wave is transmitted from this transmitting mast and it encounter a sharp edge here, then wave is supposed to be move in this direction, but it get diffracted here. So it is clear from this figure, the wave which is moving in a spherical direction got diffracted at the sharp edge. Now this angle of diffraction, this is theta, this angle of diffraction can be related as d sine theta is equal to m lambda. So sine theta is proportional to lambda. It apparent that as the wavelength rises, the angle of diffraction increases. So as lambda rises, theta increases. The angle of diffraction on the other hand diminishes as the wavelength decreases. So in a problem it is given that radio wave is of a wavelength 1.5 kilometer. For a radio wave, it is given 1.5 kilometer, which is equal to 1.5 into 10 to the power 5 centimeter. And for microwave, lambda is given 1.5 centimeter. So it is clear that the wavelength of radio wave is much greater than the wavelength of microwave. Therefore, the diffraction angle of radio wave will be more than the diffraction angle of microwave. Therefore, we can say that the radio waves are reflected by the mountain, but the microwaves are not because of higher wavelength. So out of this, option B is correct. Waves are emitted from the two coherent sources. Which statement about the waves must be correct? So we know that the coherent source of light are those sources that emit light wave having same frequency, same wavelength, and in the same phase, or they have a constant phase difference. So as per the definition of coherent source, it's having a constant phase difference. So option C is correct. The diagram shows a screen that is a distance L from the refraction grating. The grating has a total number of n lines. Any two adjacent lines are a distance d apart. The beam of parallel light of a wavelength lambda is incident normal on the grating. Which quantity affect the distance between the first order diffraction maxima on the screen? So let us redraw the all situation here. So there are n number of slits, and this distance is L. So this having angle theta. Let it be drawn from the mid. So this angle is 90 minus theta. Let draw a parallel line along this. So this angle will be theta. Therefore this angle is also theta. We know that for the diffraction grating, d sine theta is equal to n lambda. But here it is given in the question, it is the first order diffraction maxima on the screen. So for the first order diffraction maxima, n is equal to 1. So d sine theta is equal to lambda. So sine theta is equal to lambda by d. If theta is very small, in that case sine theta is equal to or near to theta, and it is also near to tan theta. So for tan theta we can write, let this is y length. So for tan theta we can write tan theta is equal to y upon L. So sine theta is equal to lambda upon d. So in place of sine theta, because sine theta for very small angle theta, sine theta and tan theta are nearly equal. So for tan theta we can write this is equal to sine theta y upon L, and from here it is written that lambda upon d is equal to y upon L. So y is equal to L lambda by d. So in the question, which quantity affect the distance between first order diffraction maxima? And so we have find y is equal to L lambda upon d. It means the distance between the first order diffraction maxima is depend on wavelength, is also depend on the distance between the slits. It also depends on the length L, but it not depend on n. So option A is correct. A wire carries a current of 0.10 microampere. The potential difference across the wire is 10 millivolt. How much energy is dissipated by the wire in a time
10 second. So we know that the power is equal to potential difference into current. So power is energy per unit time, which is equal to VI. So E is equal to VIT.
So this is equal to V is 10 millivolt, 10 into 10 to the power minus 3. I is 0.1 microampere, 0.1 into 10 to the power minus 6. Time is 10 second. So this come out to be 10 into 10 to the power minus 9. So this is 10 nanojoule. Option D is correct.
Potential difference is equal to energy transfer per unit charge. Which graph represents the way the current I through the filament lamp varies with potential difference V across it? So we know that V upon I is equal to R. So I can be written as 1 upon R into V. If we draw I versus V diagram, it is similar to Y is equal to Kx of a straight line. So where Y is I and X is X. On the X axis it is a potential difference, and the slope K is equal to 1 upon R.
So the slope of IV curve is 1 upon R. So as the current increases, the temperature of the filament in the lamp increases, because H is directly proportional to I square. Since the filament is a metal, the higher temperature causes the increase in resistance. So with increase in I, the temperature of filament will increase, and in turn the resistance of the filament will increase. So this will increase resistance of the filament. So when the resistance of the filament increases, 1 upon R decreases, so the slope of IV curve will decrease. So out of this we have to find the one which having a decreasing slope. So between this, option B having a decreasing slope. So here the slope is this. As we proceed, the slope is keep on decreasing. So option B is correct.
So there is a two wire P and Q. The details of P and Q are given. We have to find the cross sectional area of wire Q, where the cross sectional area of wire P is cross sectional diameter. We have to find the cross sectional diameter of wire Q, where the cross sectional diameter of wire P has given. So we know that R is equal to rho L upon A. So for wire P we can write R is equal to, because resistance is R is equal to rho L, length is L, and A is the area of wire P. And for wire Q we can write 1 upon 4 R is equal to 1 by 3 rho, length is 2L, upon area of Q. So this is equation 1 and this is equation 2. So if we divide equation 2 by equation 1, we got 1 by 4 is equal to, R will kill R, 1 by 3 rho into 2L upon AQ divided by rho L by AP. So this rho will kill this rho, this L will kill this L. So this will become AP upon AQ into 2 by 3. So we can write 1 by 4 is equal to, AP is 1 by 4 D square T is the diameter of wire P upon pi by 4 into dq square into 2 by 3. So from here we can write dq upon d is equal to under root 8 by 3. So dq is equal to 1.64 t. So out of this, option B is correct. A cell has constant electromotive force. The variable resistance is connected between the terminal of the cell. The resistance of the variable resistance is decreased. Which statement about the change of the cell terminal potential difference is correct?
So when the resistance of the variable resistor decreases, then the current flowing in this will increase, which in turn more number of charge will flow through the circuit. Now we know that the terminal potential difference across a battery is the work done per unit charge through the battery. So terminal potential difference is equal to work done per unit charge. Now the charge has increased, so this value will decrease, so the potential difference will increase. In other word, so now if the charge increase, this value will decrease, so the potential difference will decrease. In other word, we can say that the potential difference will decrease because more work has to be done to move a unit charge through the internal resistance of the battery. So option A is correct.
Kirchhoff's two law for electrical circuit can be derived by using conservation's law. On which conservation's law do Kirchhoff laws depends? So from the Kirchhoff first law, we know that the sum of current entering any junction in the circuit must be equal to the sum of current leaving the junctions. So here I1 plus I2 plus I3 is equal to I4. So if I multiply it by time t, so I1 into t plus I2 into t plus I3 into t is equal to I4 into t, which is Q1 plus Q2 plus Q3 is equal to Q4. So this is a conservation of charge. The sum of charge entering at a point is equal to the charge outgoing charge. Now for the second law, the sum of potential difference across all element around any closed circuit loop must be 0. So if I apply a Kirchhoff law here, we can write E minus IR is equal to 0. So if the charge move around a closed loop circuit, it must gain some energy. So if some charge, if current is flowing, it means that some charge is flowing in this circuit. It means that it gains some energy here, and then it lose some energy here. So it must gain as much energy as it lose. So this can be summarized as the gain in energy by the charge is equal to corresponding loss through the resistor. So basically this is the conservation of energy. So out of these three, option B is correct. A battery of electromotive force 10 volt and internal resistance R is connected to three resistors R, 2 ohm and 15 ohm as shown. The current of 0.45 ampere is in the resistor of the resistance 2 ohm, and a current of 0.48 ampere is in the resistor of resistance 15 ohm. So let's say this point is A and this point is B. So potential difference between A and potential difference between V is equal to I into R. I is 0.48 into R is 15, which come out to be 7.2. Voltage across the battery is equal to electromotive force of the battery minus I into R. So this is I. So from Kirchhoff first law, we can say that I is equal to 0.45 plus 0.48. This come out to be 0.93. So voltage is 7.2, EMF is 10 given here, minus I is 0.93 into R. So from here we can find R is equal to 10 minus 7.2 upon 93. This come out to be 3.0. So internal resistance of the battery is 3.0. And again we can write the potential difference across AB, which is 7.2. This is equal to current across the AB, which is 0.45, into the total resistance, which is R plus 2. So from here we can find R is equal to 14.74, is equal to 14. So out of this, option A is correct. Internal resistance is 3, which is given here. Internal resistance is 3 and capital R resistance is 4. So the battery of negligible internal resistance is connected in series with a thermistor and a fixed resistor of resistance 14 kilo ohm as shown. The table shown the resistance of the thermistor for a given temperature. For 20 degree is 12 and for 50 degree is 5. The potential difference V out across the fixed resistor is 4.5 volt when the thermistor is at a temperature of 20 degree. What is the V out when the thermistor is at a temperature of 50 degree? So we can write V out is equal to 12 upon 12 plus R. R is the resistance of this thermistor into potential difference E. Let's say E is the EMF of this battery. So for 20 degree we can write 4.5 is equal to 12 upon 12 plus 12. R is 12, it is given for 20 degree. R is 12 into E. So from here E is equal to 9. Again we can put the value for 50 degree. So V naught is equal to 12 upon 12 plus 5 into 9. So V naught is equal to 12 upon 17 into 9. This come out to be 6.35 volt. So out of this, option C is correct. 38. What is the conclusion from the alpha particle scattering experiment? So we know that in an alpha particle scattering experiment, a beam of alpha particle strike on the sheet of gold foil, and it was found that the most of the particle went through the foil, but a very few, maybe 1 in 20,000 particles bounce back as though it has hit some solid. After tracing many particles and examining the pattern, the Rutherford deduced that the atom must have nearly all its mass and a positive charge in a central nucleus, which is smaller than the atom itself. So from this conclusion of Rutherford, we can say that the nucleus contains most of its mass of the atom. Americium 241 is a radioactive nuclide used in smoke detectors. It undergoes alpha decay to form a nuclide X. This decay may be represented by equation shown here. What is the value of A and Z? So A can be written as 241 minus 4 and Z can be written as 95 minus 2. So this come out to be 237 and this is 93. So option A is correct. A top quark has a charge of plus 2 by 3 E, where E is the elementary charge. What is the charge of anti-top quark? We know that the quark is a type of elementary particle and a fundamental constituents of matter. So for every quark there is a corresponding type of antiparticles known as an anti-quark, known as an anti-quark.
it's having equal charges in magnitude but opposite sign. So anti quark having equal charges of a quark but opposite sign. So the here the charge is given plus, so here the charge of quark is given plus 2 by 3 e. Therefore the anti top quark charge is minus 2 by 3 e.